So now that we have looked at the macro to define if one of the syscalls, you actually also need to expand the code definition in another file that we're going to talk about later as follows. So you have to basically define your syscall using ASM linkage, which is the modifier, and then long, which is your return type. And then if this is the name of your syscall, so if, for example, in your project, the name of your syscall is basically get data, then you would define it as sys underscore get data and any input that you would like to add, which might be the user ID in our case, for example, in the project, in the assignment case, sorry. ASM linkage is basically a modifier on the function definition, and it is a directive to tell the compiler to look only on the stack for this function's arguments. So it tells the function that tells the compiler how this function will actually get its arguments. One way to actually make your assignment easy would be if you just implement it such that it returns the current user. I will accept these as valid results for the assignment. But if you're able to basically add on stuff, then you, as we agreed, you get more credits by doing more stuff. Anyway, the get PID system call is defined as sys get PID in the kernel, and well, this is the convention for naming it. You also have syscall numbers because, well, each system call will get an assigned number, and the way that the application or the user level call will be to the system call will be using that number. So this number needs to be unique, and it needs to be unique throughout the kernel. So you cannot have two syscalls with two similar IDs. And that also means that for backwards compatibility, if you had a system call that you have removed from your kernel, I mean, we're talking about hardcore kernel development here. If you have removed one of your system calls, you cannot reuse the syscall number because then it might be that some other application is, well, I mean, the programmer didn't know or they is using an old library basically, and that basically results in it using the old syscall number that you just removed. And then if you reuse it to do something else, then you might end up with complete havoc in your system and your system be extremely unstable. So processes do not refer to the syscall by name, just but rather by the number. And you keep the number per syscall in what is called the system call table. And the syscall table on x86-64 architecture is this table, and if you look through the internet, Linux 2.6, the older versions, you'll find in the tutorials, for example, adding syscalls, a different architecture for syscall tables. Basically, the x86 syscall table was not in this file, but was somewhere else. But let's not talk about it. We're now at kernel 4.x. I can't remember 4. What now today. And then for ARM64, and actually for most architectures, you have a generic table for syscalls that basically stores the syscall name and the syscall number, and the kernel can basically from that the kernel can basically say, okay, I got a 4 and 4 is the right syscall. I should do something right, basically. And that's the place to basically look at it. Okay, it's ASM generic slash unistd.h, but also, I mean, you find it sometimes, you sometimes find redundant information in the kernel because, well, some different parts compile differently. But I mean, this is basically where you find the syscall tables, these two. And this one, the second one, is actually your entry point to implementing the assignment to add new system calls basically to the system call tables. So this is the syscall table for ARM64, and it looks something like this. You have basically, so these are the syscalls. So sysio get events, for example, and it has the number 4, and this sysio submit, and it has a number 2, and sysio cancel, and it has a number 3, and you can see that this is how the syscall numbers are defined in the unistd.h file. Okay, and I also thought that it might, since we have been talking about the get PID a lot, so this is basically the definition for the syscall number for get PID, and it's 172, and this is a standard. So I mean, when you redefine it, when you define your get data, that's cool. I mean, you call it whatever, but that's the say that in your assignment you're going to use the name get data, then you would basically need to define the new number as last underscore underscore nr underscore get data and put a number, and this number has to be unique, and then you basically need to find what is unique and where is unique. And it's actually pretty well documented. You see, and one thing to note, I mean, if you're adding a new system call, you should basically add it towards the end. You should never come and say that, oh, I am going to add it here and shift everything that comes below by 1, because that will basically completely screw up your kernel. So you add your new system call, you define the number towards the end, and that number should not be taken, should not be here. Okay, so this is the syscall table for ARM64, and this is the one for basically x86. Okay, so and you get basically the number. I mean, this is the definition: number, ABI, name, and entry point. And we are not going to really talk about the ABI now, but ABI is, well, is it something that is 64-bit specific or 32-bit specific? We have not talked about the register sizes, but we'll talk about that a bit later. And basically the system call name and the syscall definition, basically. Okay, but when you define a system call, you also need to define sys and to add it to sysni syscall, which is basically a place to put all those calls that no longer exist. So if you are as a kernel developer, go on the Linux kernel list and decide with Linus Travel and the other guys that, oh, we do not want this system call anymore, we should remove it. So for backwards compatibility, you should actually add this as to this file as something that has already been deleted, no longer exists. But also, you need to add your new call here too. And the reason is it provides failure mechanisms so that you can fall back to this. So if you suppose that you did not get your implementation right for the system call, you don't want your whole system to break because, well, the system call does not exist, break, right? So you basically define it also here. And basically, I mean, the way things would work is that it will try to find it first in the syscall table. If it does not, then it will just jump here. Okay, so these are two things to, or this is one thing to note when defining system calls.